The question is, consider the integral over c sin x by x square into x square plus 4, where c is a counterclockwise oriented circle defined as mod x minus I is equal to 2. The value of the integral is 4 options A, B, C, D given. This question is from engineering mathematics from the topic complex variables, subtopic complex integration, GATE 2021. The solution is so C is a positive direction, that is counterclockwise is also called positive direction or anti-clockwise direction. Actually, complex integrations means that is z variable, but in place of z it is given x. Here x is a complex variable. So first write the curve equation. C is mod, that is C is means curve equation is x minus I is equal to 2. This is a circle having center at small I and radius 2. Next, find the singularities of the integrand. This is our integrand. Sin x upon x square into x square plus. Usually, singularities are obtained by equating denominator of the integrand to 0. That means x square into x square plus 4 equal to 0 implies x is equal to 0 and x square is equal to minus 4. This simplifies to x is equal to plus or minus under root minus 4. So root minus 1 I root 4 is 2. So finally you will be getting the singular points 0, 2i minus 2i are the SP. That is singular point, short form SP. Now check whether these points inside or outside one by one. How do you check? Substitute each singular point in the curve equation. You will be having left hand side a number, right hand side a number. Already in the curve equation, right hand side number is 2. Now, for example, if I put x is 0, this becomes mod minus sign. That means plus 1. 1 less than 2. So, whenever left hand side value less than right hand side value, after substituting the singular point, such a singular point is inside the curve. Whenever LHS value greater than RHS value, after substituting the singular point, such a singular point lies outside the curve. So 0 lies inside. So this is lies inside C. Now plus 2i. 2i minus I. Mod I value 1 less than 2. So this point is also lies inside C. Minus 2i. Put x is equal to minus 2i. This simplifies to minus 3i with modulus. Mod minus 3i is 3. 3 greater than 2. So this singular point lies outside C. So such a complex integration along a closed curve can be easily evaluated by most of the problems. Cauchy's integral theorem or Cauchy's integral formula. Okay. Whenever the curve contains more than one singular point, it is best to apply or it is suggested to apply Cauchy's residue theorem. Okay. So here two singular points lies inside C, 0, 2i. You can apply Cauchy's integral theorem or Cauchy's residue theorem. Before applying Cauchy's residue theorem, at each singular point, find the corresponding residue. So, you know that types of singular points usually pole, removable singularity, essential singularity. Poles of a given integrand can also be obtained by equating denominator to 0. Okay. So, clearly, this x is equal to 0 singular point is obtained from the factor x square and the power of x is 2. So x is equal to 0 is a pole of order 2. X is equal to 2i. is a singular point obtained from the factor x square plus 4, but I can write this x square plus 4 as x plus 2y into x minus 2y. So x is equal to 2y is obtained from the factor x minus 2y, this factor having power 1. So x is equal to 2y is a pole of order 1. Therefore, residue RES short form f of x, this function now denoted by the integrand is usually denoted by f of x at x is equal to 2y. Okay. So first I am calculating simple pole. The simple pole residue is given by limit x tends to a. A is the corresponding pole or singular point, that is 2y, and x minus 2y x minus 2y into f of x, that is limit z tends to a, z minus a f of z according to the complex variable z, and z is equal to a is the pole of order 1, that is simple pole. So in this fx, x square plus 4 in the denominator already factorized as x plus 2y into x minus 2y. This denominator x minus 2y cancel with the free factor x minus 2y. You will be getting limit x tends to 2y sin x upon x square into plus, you know, the limits procedure. So this is not indeterminate form. Direct substitution x is equal to 2y, that is you will be getting, it is not a standard limit. So direct substitution limits procedure, 2i whole square, that is 4i square, 2i plus 2i, 4i. Sin ix is I sin hx. That is I can write here I sin h of 2. Whole divided by I square value minus 1. So this is minus 16i. I can cancel I. So sin h of 2 with minus divided by 6. Then sin I y, where y is a variable, I sin variable or constant hy. Now residue f of x at x is equal to 0. This is pole of order 1. Sorry, pole of order 2. So 1 by, according to the definition of residue at the pole of order m, here you put m is equal to 2. You will be getting 1 by 2 minus 1 factorial limit x tends to a. A is the corresponding pole, here 0. d2 minus 1 by dz2 minus 1 of x minus a, that is x minus 0, whole to the power m, that is whole square, into f of x. This is the procedure of the residue at the pole of order 2. So here x square cancel with the denominator x square, 1 factor value 1, 1 derivative, that is here limit x tends to 0. So here a small mistake, I wrote z variable, but it is x variable. Dx. Now this is limit x tends to 0. D by dx of sin x divided by x square plus 4, x square plus 4 with respect to x derivative, quotient rule procedure. So limit x tends to 0, u by v rule, x square plus 4 into sin x derivative with respect to cos x minus sin x into x square plus 4 derivative with respect is 2x divided by x square plus 4 whole square. Since quotient rule difference. Now in all this put x equal to 0, we will be getting cos 0 1, sin 0 0. So the first one is 4 minus this is 0 divided by 4 square. So you will be getting 1 by 4 simplified. So therefore by CRT, that is full form of CRT is Cauchy's residue theorem. Integral over C f of x dx is equal to 2 pi I into sum of the residues at the poles. That is the singular ones. Residue f of x at x is equal to 2i plus residue f of x at x is equal to 0. So this is 2 pi I into the first residue value minus sin h2 divided by 16 plus the second value 1 by 4. Now this can be written as pi I by 2 minus I times pi sin h of 2 divided by 8. So here 2 is multiplying with 1 by 16 simplifies to 1 by 8. I is not simplifying minus sin. So in options, sin 2 is there. That is here I can write instead of I sin h2 sin I2. I can write here or sin y with minus 69 because according to the options. So finally this is this term pi by 8 sin 2i. So all options, so sin 2i is there. There are two options pi by 8 with minus, but don't say option D. Here this term missing. So no option is matching. So marks to all students. So this is end of the solution. The question is for a vector field D, that is the letter to be bolded, capital T is a vector, is equal to rho cos square phi a rho plus z square sin square phi a phi in a cylindrical coordinate system rho comma phi comma z with unit vectors a rho a phi and a z comma the net flux of D leaving the closed surface of the cylinder in bracket rho is equal to 3 comma 0 less than or equal to z less than or equal to 2 round off to 2 decimal places is. This question is from engineering mathematics from the topic vector calculus and subtopic that is flux surface integral related problem. The solution is, so here cylindrical coordinate system vector is given, Cartesian coordinates is xyz, cylindrical coordinates o5 and row limits that is maximum 3 here 0 to 3, check limits 0 to 2, 5 limits usually 0 to 2 pi because closure surface of the cylinder. When SC is a closure surface, that is here T instead of S, that is surface, then you can apply Gauss divergence theorem for finding the net flux of T leaving. Okay, so solution. Let the given D vector, the cylindrical coordinate system, usually the vector is because this is a vector, the arrow component multiplied by d rho, a phi component is d phi, kz is absent, but I can write 0 and kz. So rho cos square phi into a rho plus z square sin square phi into a phi plus 0 into a. Okay, so be a vector in cylindrical coordinate system. The unit vectors arrow a phi aj. Usually that unit vectors coefficients are denoted by d rho d phi dz because e is a vector. If it is a vector e rho e phi ez. So I am denoting the components arrow a phi az respectively. This is and this is and this is. So this is denoted by d rho and this is d phi and this is dz. Okay. 0, d5, dz are the components of the vector d along the unit vector that is along arrow a5, az x-axis. Okay. So, because divergence theorem we are going to apply closure surface given. So, first find divergence. Guys, divergence of this vector field d is equal to the formula 1 by rho into dou by dou rho of rho into d rho plus dou by dou phi of d phi plus dou by dou z of dz. In Cartesian coordinates, this divergence d is equal to dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z, where f1, f2, f3 are the components of the vector f bar along x-axis, y-axis, z-axis. That is I, j, k cap portions respectively f1, f2, f3 in Cartesian coordinates. Okay, so this is 1 by rho into dou by dou rho of rho times d rho. D rho, rho is already there, rho into rho square cos square phi plus dou by dou phi d phi z square sin square phi plus dou by dou z of dz 0. So this is 1 by rho into. So with respect to rho phi constant, with respect to phi z constant. So this simplifies to 2 rho cos square phi plus z square 2 z square sin square phi derivative with respect to phi is 2 sin phi. 2 is already multiplied. Sin phi derivative cos phi. And that dou by dou z of 0 is. So this simplifies 2 cos square phi plus z square by rho 2 sin phi cos phi can be written as sin 2 phi. So this is the divergence. This is also can be written as 1 plus cos 2 phi. Better 1 plus cos 2a from trigonometry is 2 cos square phi or not. So why we should write like that? Because in integration it is easy. So therefore the question, the net, that is electric nut. Okay, no problem. Therefore electric flux also. The net flux of capital D the vector leaving the closed surface usually denoted by S, that is cylinder, is given by double integral over S, the vector D dot ds bar. Okay, so you can write because D is already letter to be bolded. Think like that. S is also letter to be bolded, or you can write better to understand in a good way. So D bar, ds bar, mathematical notation like that here also. Okay. Okay, dive deep. It is better. Good language. Okay. So according to Gauss-Levin theorem, this is integral over V dive of D vector divergence of the vector D into D. So you can write single integral or triple integral also, no problem. Single integral over V, triple integral over V, both are same since by Gauss divergence theorem. So dV means derivative of volume element according to Jacobian. This is rho times 0 d5 dz. So one integration with respect to rho between the limit 0 to 3. The second integration with respect to 5 between the limit 0 to 2 pi cylindrical surface. This is the rotation cross section area. This is the rotation, complete rotation means 0 to 2 pi. Set limit is already given 0 to 2. So this is equal to you having two elements. One plus cos 2 pi and the other one which are multiplied by rho here. That is 1 plus cos 2 pi multiplied by rho d rho d phi dz and the triple integral rho limits 0 to 3, pi limits 0 to 2 pi, z limits 0 to 2, plus the other term of the divergence is s square by rho. So again triple integral rho limits 0 to 2, 0 to 3, pi limits 0 to 2 pi, z limits 0 to 2, z square by rho multiplied with this rho. So rho cancel, z square sine 2 pi into 0 d5 d. Here triple integral evaluation easily because all the 6 limits are constants and the terms are also with respect to multiplication. That is rho terms, pi terms are multiplying each other, z terms. So it can be written as product of single integrals. That is rho limits 0 to 3, rho integration rho d rho multiplied with pi integration. That is phi limits 0 to 2 pi 1 plus cos 2 phi d5 into integral z limits 0 to 2 dz. There is no z term in the first term. Plus similarly here also integral 0 to 3 rho limits 0 multiplied by pi limits 0 to 2 pi sine 2 pi d5 into z limits 0 to 2 z square dz. So term by term integration. So this is equal to rho integration with respect to rho is rho square by 2 between the limits 0 to 3 into 1 integration with respect to phi is phi cos integration with respect to phi sine and then divided by 2. Here I have no place, kindly excuse me, between the limits 0 to 5 into integral dz is z between the limits 0 to 2 plus 0 integration rho between the limits 0 to 3 sin 2 pi integration is minus cos 2 pi divided by 2 between the limits 0 to 2 pi into z square integration is z cube by 3 between the limits 0 to. So this simplifies to 3 square 9 by 2 into sin 2 pi, sin 4 pi, sin pi, sin any number of pi into the 0. Sin 0 is also 0. The first term will become simplifies to 2 pi into z between the limits 2 and 0 simplifies to 2 plus rho between 3 to 0 simplifies to 3 into cos 2 pi, cos 4 pi, cos 0 all are equal to 1, cos 0 1 again. So upper limit value, lower limit value simplifies to 1. So this will become 0. and this is no use to write 8 by 3. So finally, how much you are getting? 18 point. Please check for deciding the answer. So this is not options. Up to 2 decimal places it is mentioned. So pi value 3.14, approximately this is 56.55. So the answer is 56.55. This is congested. Let me write. So this is approximately, here I am writing 56.55 up to 2 decimal places. Please check. So this is end of the question. The question is, two continuous random variables x and y are related as y is equal to 2x plus 3. Let sigma square x and sigma square y denote the variances of x and y respectively. The variances are related as 4 options A, B, C, D given. This question is from engineering mathematics, from the topic probability and statistics, subtopic random variables. The solution is so y is equal to given 2x plus 3. Y is a linear function on x. So variances, that means variance VAR notation or sigma square of y is equal to variance of 2x plus 3. 2, 3 constants. This is equal to 2 square into variance of x, since properties of variances and mean variance of ax plus b, a, b are constants, is equal to a square into variance of x, a and b are constants. So finally, variance of y is also denoted by sigma square y is equal to 4 times variance of x is denoted by sigma square capital X. So sigma square y is equal to 4 times sigma square x. This is the answer accordingly. Option D. This is end of the question. The question is, if the vectors 1.0 comma minus 1.0 comma 2.0 comma 7.0 comma 3.0 comma x and 2.0 comma 3.0 comma 1.0 in R cube are linearly dependent, comma the value of x is. This question is from engineering mathematics, from the topic linear algebra, subtopic basics, that is independent dependent vectors. So here three-dimensional vectors, three-dimensional row vectors, a row containing here 3 components or 3 elements, that is why R cube. So this is a R cube means three-dimensional elements vectors. Given these 3 vectors linearly dependent. Solution is, so each vector containing 3 elements, 3 vectors, total 9 elements, which is forming a square matrix. Consider the given 3 vectors, say x capital X1, comma capital X2, comma capital X3 as rows in a matrix A. Okay, So that means implies A is equal to, you will be getting 3 rows, 3 vectors, 1.0, 1, 2.0, 2, 7.0. I can write integer path, that is integer. 1 minus 1, 2, first vector, first row, second vector elements in second row, 7, 3, x. Third vector elements in third row, 2, 3, 1. For linearly dependent vectors, linearly dependent vectors, comma, we have either rank A is equal to number of vectors or determinant is equal to 0. That is determinant A. Here determinant is easy to applicable 3 by 3 matrix is equal to 0, or rank of this matrix A is equal to 3, because 3 is the number of vectors, that is rank A is equal to n. So this means expanding the determinant by the definition with the first row 1 into deleting first column first row 18 minus b 3 into 1 minus x into 3. So 3 minus 3x minus of minus 1 plus 1 into deleting second column first row 7 into 1 minus 2 into x. 7 minus 2x plus 2 into deleting third column first row 7 into 3 minus 3 into 2, that is 21 minus equal to 0. So gather the like terms, that is like terms to be placed at one position, the other terms at other position. So first gather all x terms, minus 3x here, minus 2x, simplifies to minus 5x. Next, numbers, constants, the terms not containing x. 3, here 1 into 7, 7, 3 plus 7, 10, and this 21 minus 6, 5, 5 into 2, 10, 10 plus 10, 20 equal to 0. This simplifies and gives the value of x is equal to 4. Let me check. 21 minus 6. Oh, this is 21 minus 6 is 15. 15 into 2 is 30. So 30 plus 10, 40. So that x value giving 8. Kindly excuse me. This is 40 and this is finally 8. So minus 5x plus 40 is equal to 0. X is equal to 8. So the answer is x is equal to 8. This is end of the question. The question is, consider the differential equation given below. Dy by dx plus x divided by 1 minus x square into y is equal to x root y. The integrating factor of the differential equation is 4 options A, B, C, D given. This question is from engineering mathematics, from the topic differential equations, subtopic first order equations. The solution is here. This equation is the first order and first degree equation. That is dy by dx, order of the derivative is 1 and it's having power 1. And usually such equations almost can be solved by either variable separable method or linear equation method or Bernoulli's equation method or exact differential equation method. Not all first order equations can be solved. Please remember. Okay. So here y power half, which is not equal to 1. This is not a linear equation y. We cannot separate the variables. That is y terms with dy at one place and x terms along with dx at other place. We cannot write like that. So variable separable not possible, linear equation not possible. Let me check Bernoulli's equation. So the given equation can be written as dy by dx plus, I want to put x by 1 minus x square in bracket into y is equal to x times root y can be written as y to the power 1 by. So this looks like equation 1 is a Bernoulli equation in y, that is dy by dx plus p into y is equal to q into y power n, where n not equal to 1. So this is p comma q may be constants or functions of x. This term is q, and from this term n is equal to 1 by So this is a Bernoulli's equation. EQ means equation. Y variable, that is dependent variable here, if we consider it. So the next step to proceed finding the integrating factor means we should reduce this Bernoulli equation into linear equation in Y. Linear equation in Y. Okay. So what is linear equation in Y means dy by dx plus p into y is equal to q. So that means we should eliminate the right side y term. That means dividing both sides by y power half. Dividing both sides by y to the power 1 by 2. We get y to the power minus 1 by 2 into dy by dx plus x divided by 1 minus x square into y divided by y to the power half is y to the power half is equal to x. Let us say this is equation. Okay. Now we should take the substitution, that is to make this problem into linear equation in y. What is the substitution that I am writing here in the margin? Put y power 1 by 2 is equal to u. The new dependent variable is u. So this is the substitution variable. Now this term, what happens? So when you take the substitution, differentiate with respect to x because the question has the term first term dy by dx. So differentiate with respect to x. So it looks like x to the power n, whose derivative is n into x to the power n minus 1. That means half times y to the power half minus 1 is minus half into we should multiply y derivative with respect to x, that is dy by dx is equal to u derivative with respect to du by dx. So with this two steps, it is now reducible to linear equation as below. So this can be written as the first term 2 times du by dx plus x divided by 1 minus x square into u is equal to x. Now eliminate the pre-multiplication constant to make the problem into linear equation, that is derivative coefficient is always 1. So dividing by 2, you will be getting du by dx plus x divided by 2 times 1 minus x square. This term multiplied by u is equal to x by 2. This is the latest equation having the variables u and x, where u is having power 1. There is no other term containing u, only the derivative du by dx and having power 1. U by dx and u are not multiplying. So I can say that this is a first order linear equation. U is a first order linear equation in u variable. So this is your latest P, which is denoted by P1. This is the latest Q, which is denoted by Q1. To overcome the confusion between from the equation 1 P and Q and equation 3 latest equation linear equation. So IF. Therefore, IF means integrating factor short form. E to the power integral P1 dx. So it looks like f dash x by fx, where 1 plus x square derivative is minus 2x. There is no minus 2. What to do? Multiply and divide by 2. Multiplying and dividing by minus 2. So I can write this is e to the power minus 1 by 4 integral minus 2x divided by 1 minus x square dx. So I can write like this. Minus 2x into minus 1 by 4 is x by 2. Now integral f dash x by fx is log fx. So e to the power minus 1 by 4 into log of 1 minus x square. To eliminate exponential and logarithm, they are contrary to each other. Shift minus 1 by 4 to the power using properties of logarithm. I can write this is e to the power log of 1 minus x square whole to the power minus 1 by 4. So this simplifies to finally 1 minus x square whole to the power minus 1 by 4. Since e to the power log natural logarithm to any term, x term, y term, any term is equal to simplifies to that term only you will be getting. So the answer is 1 minus x square whole to the power minus 1 by 4. Accordingly, option A. This is end of the question. The question is, a real 2 cross 2 non-singular matrix A with repeated eigenvalue is given as A is equal to x minus 3.0, 3.0, 4.0, 2 by 2 matrix, where x is a real positive number. The value of x rounded off to one decimal place is. This question is from engineering mathematics, from the topic linear algebra, eigenvalues. The solution is so what is the procedure for eigenvalues? That is characteristic equations. The characteristic equation of the given matrix A is determinant A minus lambda into I is equal to 0. So without writing, we can write directly subtracting lambda from each diagonal element only. We'll be giving this 2 by 2 determinant characteristic equation. So x minus lambda minus 3.0, I can write simply minus 3. 3.0, I can write simply 3. 4.04, subtracting lambda. So this is originally, this is obtained by determinant A minus lambda into I is equal to 0. So now expanding that 2 by 2 determinant AD minus BC, x minus lambda into 4 minus lambda plus 9 is equal to 0. So arranging into highest degree term to constant term. So lambda square. Next, there are two terms of lambda. Take lambda, that is here, minus 4 lambda minus x lambda minus of 4 plus x into lambda. I can write after taking lambda and minus common plus constant term in this two factors is 4x and this is 9. 9 plus 4x equal to 0. So this is a quadratic equation in lambda. Second degree polynomial equation. Now repeated eigenvalue. So a quadratic equation having two roots, the two roots are repeated. So for repeated eigenvalue lambda, that is two, because a quadratic equation has either two distinct roots, real roots, or two real equal roots, or two imaginary roots. Imaginary roots always occur in pairs. So here two roots automatically repeated means real only. Two equal roots, real roots, comma, we have discriminant equal to 0, that is b square minus 4ac is equal to 0. Here a is equal to lambda square coefficient 1, b is equal to lambda coefficient, that is minus 4 minus x, c is equal to constant term, that is term independent of lambda, 9 plus 4x. Now simplifies to b square, that is I can write directly 4 plus x square minus 4 into 1 4, 9 plus 4x equal to 0. So this is expanding a square plus 2ab plus b square minus 36 minus 16x equal to 0. So which implies x square minus 8x minus 20 equal to 0. So minus 8x can be written as minus 10x plus 2x. Minus 10 plus 2 is minus 8. Minus 10 into plus 2 is minus 20. Exact factorization. So this can be written as x minus 10 into x plus 2 is equal to 0, which implies the two values of x is equal to 10 or minus 2. So here x is real positive number. Since x is positive, there the value, required value of x, already we got x values integers, so not required to one decimal place, that is 10. So the answer is 10. This is the end of the question. The question is the vector function f of r is equal to minus x I cap plus y j cap is defined over a circular arc C shown in the figure. So this is along x-axis and this is along y-axis, I cap, j cap respectively, the unit vectors along x-axis, y-axis, and a line makes an angle 45 degrees with positive x-axis, and this is the circular arc. C is the circular arc. The line integral over C f of r dot dr is 4 options ABCD given. This question is from engineering mathematics from the topic vector calculus, subtopic vector integration, line integral. So solution. Generally, circular arc, semicircle, when it is a curve, it is better to convert the problem into parametric equation. So this is radius 1. This is one given. So center is here 0, 0. So what I am doing, parametric equations to curve C, circular arc, on x is equal to center, that is radius, here up to this 1 unit distance. From this 0, 0 to this point is also 1 unit. This is already mentioned. That is radius plus x coordinate of the center into cos t. Y is equal to radius plus y coordinate of the center into, and x is equal to x coordinate center plus radius into cos t. Y is equal to y coordinate of the center plus radius into sin t. So here center 0, 0 plus 1 into cos t, which will become cos t, and y is equal to center coordinate of the y coordinate of the center, that is 0 plus radius 1 into sin, where t is a parameter, which is nothing but sin t, where t is parameter, where t is parameter and t limits, so making an angle up to 45 degrees. On x-axis, that t value 0. That is parametric equation, means all the existing variables connected to one variable only, connected to a new variable, that is called parameter. So x is connected to a new variable t, y is also connected to a new variable t. T limits 0 to pi by 4. So therefore, dx how much? Cos t derivative minus sin t dt. dy derivative of y. Sin t derivative cos t dt. Now, therefore, the line integral is integral over c f of r dot dr. R is the letter to be bolded. This is f of r bar dot dr. So how do you get this? Is in f of r, I j respectively replaced by dx dy because er means dx I cap plus dy j cap. I can write here. Since r bar, that is the letter to be bolded, r x I cap plus y j cap. So dr bar dx I cap plus dy j cap in two dimensional because the vector is in two dimensional. If it is three dimensional, then add z coordinate, that is z j cap. So integral over c minus x dx plus y dy. Okay, so x value cos t, dx value minus sin t dt, y value sin t, dy value cos t dt. Integrating with respect to t, these two terms, t limits 0 to pi by 4, nothing but 45 degrees. So 2 sin t cos t, 0 to, which is a repeated quantity, 2 sin t cos t dt. 2 sin a cos a is sin 2a, 0 to pi by 4 sin 2t dt. Sin 2t integration minus cos 2t divided by 2 between the limits 0 to pi by 4. So minus 1 by 2 into cos 2 into pi by 4 cos pi by 2 minus cos 0 cos 90 0 cos 0 1. So this simplifies to 1 by 2. Okay. So the answer is 1 by 2. Accordingly, the option is C. This is the end of the question. The question is, consider the vector field f is equal to ax into 4y minus c1 z plus ay into 4x plus 2z plus az into 2y plus z in a rectangular coordinate system x comma y comma z with the unit vectors ax comma ay and az. If the field f is irrotational in bracket conservative, then the constant c1 in integer is. This question is from engineering mathematics from the topic vector calculus, subtopic irrotational, etc. So instead of ijk, they have given the unit vectors ax, ay, az. Okay. So the given vector function is irrotational, that is conservative, means curl f bar is equal to 0. Solution f bar. Here the letter to be bolded, that is called, sometimes instead of f bar, they will do like this, is irrotational. That is rotation free, implies conservative force field, that is also called curl f bar is equal to 0, that is 0 bar. So you know how to evaluate curl, which is a cross product, which is evaluated by 3 by 3 determinant. The first row is the unit vectors ax, ay, az. The second row, partial derivative operators, dou by dou x, dou by dou y, dou by dou. Third row, the components, that is 4y minus c1z. Next, 4x plus 2z. The next component, z component, that is az component 2y plus z is equal to g. So this simplifies to expanding the 3 by 3 determinant by the first row, ax into deleting first column, first row, operators. Dou by dou y of 2y plus z, partial derivative with respect to y will become 2. Z is 0 minus dou by dou z of 4x plus 2z, 4x 0, 2z value minus ay into deleting second column, first row, dou by dou x of 2y plus z, y and z are constants with respect to x, 0 minus dou by dou z of 4y minus c1z, 4y 0 minus c1z derivative is minus c1 plus az into deleting third column, first row, dou by dou x of 4x plus 2z, that is 4x derivative 4, 2z derivative 0 minus dou by of 4y minus c1z, 4y derivative 4, c1z 0. So this is equal to 0. So this 0 cap can be written as 0 times ax plus 0 times ay plus 0 times az. So equating like terms, you will be getting c1 is equal to 0. So the constant c1 in integer is 0. 0 is the answer. This is the end of the question.